Hey everyone, welcome back. If you are a mechatronics student and your CV says studied control systems, that is not impressive. Companies don't hire what you studied, they hire what you built. So today I am showing you how to build a line following robot under 1000 rupees and how to level it up so it actually sounds impressive in interviews. Let's get into it. Now, why build a line following robot? This project is a fantastic entry point into robotics for several reasons. First is you gain a real practical understanding of how mechanics, electronics, and coding all work together. This is the core of mechatronics. It's a move beyond theoretical textbooks. This project provides a tangible way to see control systems, the brain making decisions, work in real life as the robot adjusts its path. Third, career booster. Standing out in a job search requires real proof of skills. It showcases your hands on ability to employers. Fourth is perfect starter project. You don't need a huge budget or advanced expertise. This is specifically designed to be beginner friendly and low cost, making it an ideal first. Now we will understand the core mechatronics concept that is being applied here. So what actually happens? The sensor detects the line, the Arduino reads the signal, the motor responds accordingly. And this loop runs continuously. That's a closed loop control system in real life. You do not need expensive components for this project, just an Arduino, two battery operated motors, an L298N motor driver, two IR sensors, two infrared sensors, a battery chassis and a battery, and all of this costs roughly around 800 to 1000 rupees, so budget is not an excuse anymore. Also, you don't need to go to a physical store, you can order all these parts online. I usually recommend student friendly sites like Circuit Central, Roboda, RoboCraze. They deliver genuine Arduino boards, motor driver sensors, and even kits straight to your door. And if everything fails, and you are not able to get all these components anywhere, Amazon, Flipkart has most of the parts. Now let's actually understand what is happening physically. You just keep imagining everything from this image when I explain it to you. An infrared sensor has two main parts: an infrared LED which emits infrared light, and a photodiode or phototransistor which receives reflected light. The infrared LED continuously sends out invisible infrared rays. Now, when this light hits a surface, two things can happen. If the surface is white or light colored, it reflects most of the infrared light back to the receiver. If the surface is black, it absorbs most of the light and very little gets reflected back. The photodiode measures how much light is coming back. If a lot of light is reflected, the sensor outputs one digital signal, usually high. If very little light is reflected, the sensor outputs low. So basically, the sensor converts light intensity into an electric signal. The Arduino keeps reading this signal. When it detects low from the sensor, meaning very little reflection, it understands that the sensor is over the black line, and that's how the robot knows whether it is on the path or off the path. So technically the robot is not seeing black, it is measuring reflected infrared intensity. This works on the principle of optical reflectivity. Black surfaces have low reflectance and high absorptivity, whereas white surfaces have high reflectance. In this basic version, we use simple if-else logic. If both sensors detect white, go forward. If left detects black, turn left. If right detects black, turn right. It keeps adjusting itself in real time, and that's your logic for line follower. Now here comes the three scenarios. This IR sensor system is the eyes of a simple robot line follower. A robot usually has at least two of these IR sensors, left and right, mounted underneath its chassis, pointing straight down at the floor just in front of its drive wheels. The robot is programmed with a simple logic, that is, it must stay in the dark to stay on the path. For the line, you can use a piece of black tape on the floor, and for the floor, choose the light colored background, example white paper or a wooden floor. As the robot moves forward, the Arduino constantly loops through the process illustrated in the picture. It takes a reading from both the left IR sensor and the right IR sensor while making steering decisions. That's the logic. For the scenario A, that is the perfect path, both sensors' output is low. Both the left and right sensors are positioned directly over the black line. As shown on the right side of the image, the black surface is absorbing the infrared light and very little is reflected back. Here, both photodiodes measure low intensity. The Arduino receives low signal from both. Hence, the robot's logic concludes I am perfectly centered on the line. It continues to drive both the left and right wheels forward at full speed. Now here is scenario B, drifting left where right sensor outputs high and the left outputs low. The robot is veering, of course, to the left. The left sensor is still over the black line, but the right sensor has moved onto the white floor. On the left side of the image, the white floor is reflecting high intensity IR back to the receiver. The Arduino receives a high signal from the right sensor. So the robot knows it needs to correct to the right. And to turn it, it slows down or stops the left wheel and keeps the right wheel driving forward. This pivots the entire robot back onto the center of the line until both sensors are back over the black and reading low again. In scenario C, it is drifting right where left sensor outputs high and right outputs low. This is the exact opposite of scenario B. The left sensor has drifted onto the white floor, and to correct, the robot spin its left wheel forward and stop its right wheel, pivoting itself back to the left. Okay, so now here is where you can take your line follower from beginner level to pro level. In this basic version, the robot just says left sensor sees black, turn left, right sensor sees black, turn right. This is called all or nothing control and it works, but the robot ends up jerky. It overcorrects and zigzags like this down the track. Here is the smarter way, that is PID control. PID stands for proportional, integral and derivative. Proportional reacts to the current error, basically how far off the line you are right now. Integral looks at the sum of past errors, helps eliminate any steady drift, and derivative predicts future error based on how fast you are drifting, and it smooths the motion. The PID controller takes these three calculations and adjusts motor speed continuously instead of just turning full left or right. And the result? No jerky motion, smooth and fluid movement. That is professional level behavior. And here's the best part. This is exactly the kind of thing that makes you stand out in a job interview. You can say I implemented PID control to achieve closed loop feedback, tuning P, I and D gains to optimize response. That sentence alone tells recruiters you understand control theory and can apply it to real systems. Here is why this project actually matters. It shows that you get closed loop systems, not just theory, but real feedback in action. It shows you how to control motors and use sensor feedback effectively. Basically, it improves you can think like a real engineer, building systems that actually work. And honestly, that's exactly the kind of thing recruiters notice. Not just that you studied it, but that you applied it. Alright guys, to wrap up, this project is low cost but high learning impact. It's the perfect beginner robotics project and it gives you a strong foundation for more advanced robots. The best part, you get to build it yourself, which is exciting and super fun. You are actually learning the concepts hands-on instead of just sitting through theory and getting bored. And yeah, share your projects with me. I would love to hear all your crazy experiences like, damn, my robot just did this, or oh wow, it's finally working. If you enjoyed this video, don't forget to subscribe and share it with your friends. And of course, let me know if you want me to make more project videos like this. Okay, bye. Take care.